Hi, I'm Aimin Wen from North Dakota State University. During the past 12 months, I've been working on the detection and the pathogen detection and typing methods. Basically, what the goal is to find a more specific, sensitive assay to detect the pathogen accurately, so that would help for the disease monitor and also maybe forecasting, and particularly for the typing, it's good for the epidemiology study. So I've developed four assays. One is for the labs who don't have the real-time PCR. So the regular conventional PCR to detect the pathogen and as well as typing the pathogen simultaneously. This method improved the detection rate comparing to the previous one I developed. I talked about 2 years ago. So this method very specific, sensitive, robust, and simple. So from the PCR running to the result, you only need like 1.5 hours. It's very fast compared to previous. Normally you need 3 hours. So that could be used by most of the lab would have the facilities. The other assay I developed is to quantify the different haplotypes, because some of the infections you have the co-infection. The conventional one you cannot determine what's the ratio, because sometimes one is dominant and sometimes they're equally. The concentration equal number. So with the real time, you can determine the concentration of the bacteria, which is very important because everyone knows in plant pathology, there's a threshold of how much pathogen present there determine the severity. If you will get disease, how severe it is. So this method is like a more, numerically give you better assessment. And another method I developed is the quantitative assay in the psyllid, because there's many people working on the psyllid monitoring to see if the pathogen present in the vector. But yes or no is not as accurate as how many are there, because the number determine if the disease will happen and how severe the disease will be. So all those methods are very practical for the if they have real time, they can use those. Otherwise, they don't, the conventional PCR. So some of the primers we are shared with other labs, such as Russia's lab, and they've been using and working well for them. We haven't published them, but it's nice to share them so they can use them in their field samples. Also help us to validate. All the assays have been validated. We're going to publish them with our greenhouse work to correlate with what they do in real life instead of just laboratory. So that's I've done. And in the future, we want to use this, apply those methods in the greenhouse monitoring to see the different haplotype on the disease incident and the transmission, and also to monitor the plant and the host, the pathogen-host interaction, as well as the pathogen and vector interaction, which will help the epidemiology study, and so ultimately help to find out the best way to control the disease.